I am Nicholas Bornolis of Capital Link, and I would like to welcome you all to today's webinar. This is the third webinar in a 4-webinar series. We have the great privilege to have with us Dr. Martin Stopford, who is going to discuss with us during this 4-webinar series about managing maritime innovation in the era of change. Today's webinar is the third one in the series, and the topic today will be innovative systems to improve performance and cut emissions. So very quickly to remind everyone, Dr. Stopford is going to make a presentation, a slide presentation, and then he will be available to reply to your questions. Please, you can submit your questions at the bottom of your screen. You have the Q&A button. You can submit your questions anytime during the webinar, and Martin is going to reply to them afterwards. And without any more delay, Martin, welcome. Thank you for being with us again.
Nicholas, thanks so much, and a pleasure to be here again, and welcome everybody who's logged in. It's great to, well, I can't actually see you, but I hope you're out there. What we've done in the last 2 webinars, it seems to me, is reach 3 conclusions. I mean, the first one, I think, is that energy is going to be expensive, and that includes fossil fuels. The second one is that the investment is likely to develop in waves in green energy, and but it isn't going to be sort of one size fits all. It's going to be waves that will differ between the many market segments. I mean, there's probably 20 or 30 different market segments that will behave slightly differently. And then the third thing is that maybe coming from the first of the webinars, the cargo owners are going to develop perhaps a different sort of relationship with the sea transport business from the one which has worked very well for the last 30 or 40 years, but is really very market driven and quite adversarial, and therefore not all that suitable for a business where you're trying to develop logistics systems as well as everything else. In this session, we're going to talk about innovation and the uses of digital technology to develop new systems in all parts of the industry. And so I'll be looking at the ships, I'll be looking at the company organizations and the internal or the external global logistics. And I guess when I ran through this presentation to begin with and thought what the implications were, I was reminded of President Lee Kun-hee of Samsung's suggestion to his managers that they should change everything except their wife and kids, which was really quite, I think it sort of hits the nail on the head. It's hard to sit here and say everything's going to change. But from where I sit today, it's hard not to believe that a lot of things will change. Well, as usual, I'm going to talk to you through slides, and so if I may, I'm just going to share my my screen with you, and I hope that you are now seeing my slides, and if not, then someone can send me a message. We were playing with this quite a lot yesterday. So let me just move my camera around as well. You know, I can see the screen a bit better. Okay, well, just to sort of recap the whole agenda, I'm going to start off on digital systems with the general theme that that digital systems are very much about detail. They have to be designed, they have to be validated, they have to be applied, they have to be monitored, and then they have to be updated, the famous rolling out of updates, which is a nightmare for anybody in the IT world. And so what I'm going to start by doing is briefly reviewing the value added by digital events, requests and queries. And that sequence, events and requests and queries, is quite an important one because really it sums up most of the things that digital systems do. They record events or they notify of events. They issue requests to other systems, and they issue queries to databases. And that you'll find that these lurk at the bottom of most system applications. So it's good to get them clear at the beginning. Then from that, we'll move on to digital systems on the ship and the digital systems in the shipping company. And finally, integrated global transport systems. So that's the agenda. Let's start with part one, the value added by digital information requests and queries. And I mean, one of the aims here is to, and I'm just hoping you can see my my cursor because I'm pointing to cutting fossil fuels and implementing I4 technology go hand in hand. And that's sort of the key issue here. AI and robots have very good specific applications, but it's a niche area, I would say, and autonomous ships are a very interesting challenge and specialist. But really what we're talking about is systems that will help to run the business better. And that involves management figuring out how better systems could add value to the business. This is something that McKinsey raises. I'll revert to it later, but McKinsey say an awful lot of people start back to front. They start with the technology and they say, what can we do with this? They should start with looking for the best ways to add value and say, where do we get the technology to do this? You then have to find the best technology tools to make these new systems work effectively, and not necessarily new tools. You may be using stuff that's been around for quite a while. And then thirdly, there was plan, prototype, test, trial, develop, roll out, and be patient to make all this stuff work. And having spent most of my life in the shipping business, and particularly thinking of the last 20 or 30 years, this is not something that most shipping companies were set up to do, and it deserves a bit of thought. To just clarify this point about the use of tools of digital innovation, that's events, requests and queries, what popped into my mind as I was putting the presentation together was the old mythological story of Theseus and Ariadne and Theseus killing the Minotaur. And the reason I thought of this was that really it's quite an interesting sequence when you think about it. The events, this is Ariadne at the opening to at the door to the labyrinth, and she's giving Theseus a ball of thread. And what she's saying to him is that he's going to use that thread to plot he's going to unravel it as he walks to the Minotaur's den, and then he's created a digital, not a digital string, a thread of information which will help him to get out, and that is the equivalent of storing a digital string. Then, of course, Ariadne issues the request, please use this sword, which she gives him to kill the Minotaur. I mean, I know Theseus isn't digital, but he could be a robot, from some ancient, who knows. Then finally, the query. When he's killed the Minotaur, I don't know how you pronounce it, he queries his thread database, and that tells him how to get out of the labyrinth. And so if you put all that stuff together, you've got a lot of the main elements of an information system, including requests from the management, etc., etc. So let's move on a little bit to the shipping business and query let's do a query of tanker fleet performance. And we're going to query the tanker fleet database. And here you go. This shows you on the left-hand axis of this chart, it shows you the oil tanker fleet performance in 1,000-ton miles of cargo transported per deadweight per annum. So it goes from 5,000 to 45,000. The peak efficiency was 42,000 ton miles of oil cargo delivered in 1973 and 1974. And that falls to 2,000 ton miles per deadweight in 2023. And so we've queried our database, we've got this result. If you were the manager of the tanker business, you might very well have a board meeting to discuss why it's gone down so much. And I mean, this little table up here gives you a bit more information. The great thing is if you've got data, you can drill down, and it tells us that some very obvious truths. The oil cargo increased by 519%. This is the little table top line, 582 to 3.2 billion, 519% increase. Meanwhile, the tanker fleet increased from 71 million deadweight to 637 million deadweight. That's 895%. So we've been growing the tanker fleet a lot more than the cargo. Of course, lots of, the quick answer to that is, of course, ton miles, that people always say is ton miles. But actually, between 1963 and 2023, the average ton miles, the average distance in nautical miles has not changed at all. It's 102%. It was 4,200 miles in 1963, and it was 4,287 miles in 2023. So it's not that. What is it? Well, we might then move on a little bit more. Let's have a look at queries that might tell us answers to this question. And of course, the key point here is that you can't do the queries unless you've recorded events in a database in a form that you can query them. And that, that database has to be created from the events. An event is just a package of data saying something happened. And in this case, the pie chart shows the sorts of things that you might query from your ship operations database, and I'm sure many of you do. And this is a products tanker, quite a modern one recently. I got the numbers out of the Danish Green Ship of the Future study, and so it's perfectly kosher. This ship in a year was spending 53% of its time in transit, that's the red, 21% of its time waiting, that's the grey, 20% handling cargo, and 6% manoeuvring. And that, that tells you a very interesting story, because you're immediately drilled down to where you need to be focusing. I remember going into a cargo fleet office a few years ago, and the new manager there had taken one look at the fleet and had started doing this sort of thing in minute detail, but he wasn't actually using a database. He divided the transport profile of the fleet into 80 different topics, and he got these all around the office on sheets of paper, and he was slowly ticking the boxes and sorting them out. And that's it's a rudimentary but very effective way of tackling a management objectives problem. And of course, if you do it digitally, you find all sorts of new information that can help you. That's the first thing. And the second thing is that sometimes that information can be queried from the database, and if the answer falls into certain parameters, then it can be used to activate, to perform actions like Theseus killing the Minotaur. You make a request, or more conventionally, you know, if you go on Amazon, you issue a request to order an iPad, and that's an event. It goes into the database as an event. Just a very brief word about this whole digital events thing. I mean, I know this is highly simplistic, but one of the things that I have noted is that it is often very difficult to get information out of the telematic information out of the equipment on board ship. And one of the reasons for this is that the data has telematics which dictate, which project, they send small packages of digital data, which is binary data, and that's received, and that needs to be interpreted. And to interpret it, you need to know the exact format. And in this particular example, we've got a pump in the middle, which is showing 5, which for that pump, let's assume it means the pump's fully open. And we want to send the number 5 along the network. And the way you do it is you're going to send it in ASCII code, and you do that by looking up the ASCII code for 5, which you can get off this table here. It's these digits from this reading from left to right, and these digits reading from left to right too. And it's 1010101110. You send that to the controller, and it appears on the screen as 5, the pump's open, or it's translated into the. And so the point is that you need this binary information means nothing if you haven't got the code. And that's why it has 2 effects. One is if you've got a fleet of 50 ships with 1 million different bits of kit on them, the telematics might all have different codes, and you may have difficulty finding out what they are. So it's hard to harvest the data. And the second factor is that you do need to integrate this stuff. It's no good just sending data. Someone has to do something with it. And as McKinsey said famously a few years ago, that a typical offshore platform has 30,000 sensors on it, and only 5% of the data gets looked at, and it's generally the wrong 5%. So McKinsey seemed to spend a lot of time figuring out that things don't work very well. Well, this very dense chart, I don't know if you can see them, has 22 examples of ways of adding value in a business, a maritime business, with events, requests and queries. And so the sort of things you can do is you can do much better management accounts, which really relate to the things the board and the management are interested in. You set up the systems to generate that information with the codes that allow you to download it from the database, and very quickly turn it into management reports. I spent a lot of time doing this sort of thing at Clarkson Research. An important thing to build into this, this is an idea I borrowed off Peter Drucker, is that you should record information about things that don't happen. Because one of the problems is many of the techniques you may use to improve the performance of your company or your ship might involve stopping it doing things that are not helping performance. For example, if you do preventive maintenance, the pump that otherwise was going to break down doesn't break down, so the ship is not left high and dry in the middle of the Pacific, costing $100,000 in lost freight and repair costs. But the trouble is the fact that it doesn't break down doesn't appear in the reports. So you need to find ways to report things that don't happen. And in this third box here along the top row, you collect data on defects. And the fourth one, we monitor the use of equipment against performance limits. So you look at whether the equipment is being used within the specified performance limits. For example, a crane manufacturer puts a telematic on his crane and gets a stream of data. And when an insurance, when a guarantee claim comes in, he can check and say, oh yes, actually you used this crane to lift bigger weights than it's guaranteed for. And that's the sensors have provided him with that data. And that's just as valid to a company that doesn't want its stuff to break down as it is to the manufacturer, you know. Early signs of equipment failure, very important. That's the next one. The next one, the last one on the top, fine-tuning engine performance. I mean, this is a fascinating one. I had a friend who ran the technology department for one of the Formula One racing teams, and he had 100 people, and they didn't, you know, their job was to figure out any way possible to make the car perform better in ways you would never dream of. And then they would figure out how to get the data by putting FPGAs or sensors on the car. They collect the data, they program it, and then they put it to work if it worked. Now, and this doesn't solve all the problems, because I was doing a presentation in Hong Kong, and I quoted this, and Tim Huxley, who's a keen Formula racing man, said, well, if they're so good at it, how come they don't win more races? And I asked the guy when I saw him next why this was the case. He said, oh, well, our engine isn't very good. We need a new engine. And then there's lots more of these things. I don't think I'm going to go through them all, because they're along the same sort of theme. But basically, I'll just do the last one on the bottom right-hand side of row 3. Display information needs to be, displays are really, really important. If you read up on major accidents, it's surprising how often a good, well thought out display, perhaps with some warning applications sitting behind it, could have prevented an accident which 10 people on the bridge were serving for what was the problem, why it was, were searching to figure out why the helm wouldn't respond, you know, that sort of thing. So I'm just giving these as examples of the many things you can, if you have a vision, you can really do these things, but it's a long, hard slog to get them done. Once they're done, it puts you at the head of the pack. And then finally, in this section, the global communication system is absolutely gunning for us. We've got these 3 network areas here. In the middle, there's the cable network, which shipping was one of the first and the biggest users of the cable network. I mean, in 1873, Henry Benham, who was the key broker at Clarkson's, was down to the Baltic fixing ships. And then he'd head back 3 times a day. He'd head back to the office, cable the ship in wherever it was, and the master would pick up the cable, go fix the cargo, go and collect the cargo. It was massive saving. And I think from memory, in 1873, Clarkson spent more money on cables than they did on wages. Well, of course, brokers didn't get paid so much those days, but you get the drift. This stuff is very important. The satellites are getting much better. We now have computers. You see, started in the 50s, the first CDC supercomputer is shown 1964. These link into the cable network, and that meant from that time you could share information between computers, which is the core of what we're talking about today. It's got better and better. We now have the cloud, we have microprocessors, and we have a bunch of softwares and network systems which can be used by management to run a fleet of ships as a transport factory, integrate global logistics, and all of this is built on collecting performance data. like Ariadne's thread, designing interfaces so that you can use it easily and you can see what's going on, develop databases so that the thread is there when you need it and you've killed the monster, and creating systems which do things and displays and reports. These are all, once you start to build, it all comes together. Well, let's move on and talk a little bit about the digital systems on the ship. And today we've got 100,000 ships on the sea, and they have, many of them don't have very good digital systems at all. A few have very good systems, but I'd say generally, chatting to people, for most companies, bearing in mind, that many, almost half the fleet consists of companies with only 2 or 3 ships. This sort of thing is quite demanding. But the first big challenge is for the shipbuilders, who need to integrate the onboard systems, which you can see in this chart. We've got, this chart shows 8 different systems. Each is massive, complex, and the challenge for the shipbuilders and the equipment suppliers, people like Kongsberg, is to provide the systems which reliably deal with all these issues and can be used by the crew and are efficient. Well, the system that most ships use currently is local area networks, LANs, as they're called, and these are used to manage the sharing of data between computers and equipment with computers embedded in them. And this little drawing here shows a typical LAN. It's a simple arrangement. It uses, LANs run the Ethernet protocol developed by Hewlett-Packard in the 1960s, and it consists of wires with Ethernet plugs. You've all seen them, and it's a wonderful system. You just plug in the Ethernet into a switcher hub, and the switch the hub will transport data from from the provider, providing units to the device that it wants to send it to. Very often definitely on the bigger systems, you'll have a server which, in addition to storing files, central files, which everybody can access, which is a key thing. It also has apps which everybody can use, and all of this can plug into machinery, etc. So a LAN can support a wide variety of compatible network devices, such as firewalls, etc., and you can plug peripherals into it. And indeed, most of the computer systems today on ships are based around local area networks of this sort. And this is an example of a navigation system, and you have the LAN with 2 different loops dealing with navigation screens, controls, and links into sensor interrogation. Here you've got a link into a network gateway, and on the other side is a network of sensors, and and there's 2 of those. And these are the sorts, down at the bottom, of the sorts of sensors that they're communicating with. Of course, this is all looks beautiful. In the left-hand side is the nice control console, but of course in the background there is a lot of wires, and given that ships are at sea, things take time. Rolling out upgrades is difficult. You roll out one upgrades to one system and it screws up another system, that sort of thing. The bigger and more complex the system, the tougher it gets. And ideally, this sort of system integration is done by the shipbuilders. And the problem really here is that anyway, integrating systems and making them work is very difficult. And again, McKinsey did a lot of surveys on this, and they reckon, this is a few years ago, about 5 years ago, they reckoned then only 30% of manufacturing companies were actually getting value from using their digital data. One of the classic, they came up with this wonderful thing called pilot purgatory, where what happens is you develop, everyone gets enthusiastic, you develop the new system, you test it, you develop the pilot scheme, you test it, and you start to roll it out, but for some reason it never gets out of the pilot scheme level. It's very hard to roll it out. And I've tried it. I remember trying very hard with a sales and marketing system. It is very difficult to roll out a new system while you continue to operate a business with another system. A major problem for developers, this is another McKinsey point, is that you focus on the technology rather than finding value added and working back to the technology to deliver it. And there are often lots of organizational problems in implementing this. Governance is who's in charge. You know, the ship-shore issue, I mean, let's not pretend that's not a problem. Anchoring, it's a problem that's solvable. I mean, I've seen, but it's a tricky one. And anchoring, that's reverting to old ways, is well known. Lack of clarity on what is business value, what is really adding value. Limited people and financial resources, too many potential use cases. Projects get stuck in pilot purgatory. And today's shipping companies were not really designed to do this sort of thing. And that's why the president of Samsung, you know, got it right, really. And indeed, look at Samsung today. They got out of that very difficult place they were in the early 90s. The problem for shipbuilders, though, is massive. I mean, this chart, sorry, it's another McKinsey chart. I hope McKinsey don't mind me quoting their data. This shows the number of the number in a product run. So it goes from 1 to 1 million. And this shows the number of products the company's managing, which goes from 1 to 12. So, you know, if you're doing smartphones, it's you have one or two products and you make 1 million at a time. If you're doing shipbuilding, you might have 8 products and you're only producing 2 or 3 if you're lucky, often just 1. And having, you know, from my days in shipbuilding, it's a nightmare. You know, first time round the buoy with a new ship is a nightmare. But it's great to see the shipbuilders are moving into smart shipping. This is the Daewoo DSME brochure that I just picked up the other day. I haven't had a chance to talk to them about it, but it's saying all the right things. And there's no doubt about they're trying to move down the road to do this. But to go down this road, it does take 2 to tango. You know, the customer has to input, and you'll notice all of these systems, when you read the marketing literature, they emphasize again and again the need to adapt to customers' needs and the needs to get customers involved. But this looks to pretty good. It's got heavyweight technical backing, and it's a very big step down the road, I would say, from where we were 5 years ago. And apologies to all the other shipbuilders I'm not mentioning, who I'm sure are doing the same thing. And if I'm not saying it right, give me a call, please. One of the most important systems today is the Kongsberg KChief comprehensive system. They tell me I think they have it on 10,000 ships now. It's a standalone system covering many onboard functions. Modular hardware and software applications are combined to meet vessel requirements, and this reduces interface requirements. I'm just quoting from their literature here. So they're trying to deal with the high variety of systems by modularizing, using different lands. which are modularized so they can work together. Its modular design is connected by local data networks with distributed processing. Well, and what you're trying to do there is, because speed and timeliness is so important in these systems, they split the job into bits and they perform it close to the processor, so that you don't have long cable lags as messages go back and forwards. The whole thing is performed very, very quickly with this distributed processing system. And you find, you know, this speed and timeliness of system response is a very big issue because ships are so big. Integration allows vessel operations to be covered consistently with information flow through the whole system. And there's a list here of the areas they cover. It's everything. And it's fine, but of course, lands are lands. You know, it's fairly aged technology, nothing wrong with that. But there are one or two other network systems which, for certain applications, can get over the integration issue and the speed issue, perhaps better than a LAN, because a LAN is a serial system, whereas a control area network that I'm showing you in this chart is a synchronized system. Everybody, all the systems on the network, here's your backbone, and these are the systems. Each system sits behind an electronic control unit, and the electronic control unit just plugs into the network. And you've also got sensors around the ship which plug into this network. Basically the systems talk to each other in a synchronized, simultaneously. It's all synchronized, and it's a bit cleverer than that, because the big thing about this canvas system is that it checks the priority of the message, and each of these systems, as it publishes a message onto the backbone, it goes through it digit at a time and sorts out which is the most highest priority message, and all the others back off, and the highest priority message gets sent first, which may not sound much, but when you've got a big system and you need to do certain things instantly, and you need really to concentrate your resources perhaps in one of these systems which is working hard, it means that you don't get a bunch of other garbage coming in from unimportant systems. It is a very, you know, the control area network. And it's this which revolutionized cars. I mean, it was introduced in the 90s. It got rid of most of that awful wiring you used to have in cars. You had, you know, great big spools of you know, great bunches of wires, which were a massive cause of deterioration. And you know, instead of, you put a control area network into the car, and instead of having a switch on the dashboard that you switched electric current in, and it went down a wire to the back window, you simply, the button sends a message down the canvas backbone. It's received by the back window motor, which opens the window. And just to make it better, if the window gets jammed, there's a little program checking that, and if it is jammed, the program immediately stops the motor. So, you know, once you go down these roads, you open the door to doing a lot of clever things, but someone has to be smart enough to tell the programmers and the system builders what you want, and to make sure that once it's done, you do actually get the product as you know, you do get the information working for you and adding value. You know, as McKinsey says, producing data is of no value at all. What matters to Theseus is the piece of thread. It's no good giving a bundle of wool. He needs the piece of thread that he laid, you know. And this slide 15 shows an example of a controller area network using a protocol called NMEA 2000, which is designed for boats and ships up to about 100 feet, I think it is. It's fairly small, but this is a proprietary system. What is so wonderful about this is these are the backbones, and you've got all these bits of kit. You know, this one, number 6, is the course computer. All you do is you have a standard plug. The switch box arrive. You plug it into the plug in the backbone with the standard proprietary switch, and you plug it into the mains as well. That's that one, and off you go. It works immediately. It's plug and play, and you know, you can see all the different bits of kit are plugged together. And I mean, you know, if you go on YouTube, you'll see a guy fitting one of these systems to his boat. It's so it's not rocket science in shipping. As always in shipping, it's not that it's rocket science. It's that the ships are so big, so complex, it's overwhelming. And, you know, you need an organization capable of not being overwhelmed to do it. Which brings us to shipping company systems. And I'm going to speed up a little bit now because I'm taking a bit longer than I expected. But some of the key tasks for smart ship management are, first of all, integrating management across the transport chain. You need to get everybody linked together on some sort of network. Secondly, develop ship and shore personnel into a productive team. That's the goal. You get them. I mean, you know, if you've got you know, 20 or 30 ships, you've got far more people at sea than you have on land. And with the communications, they keep putting up these satellites. There's some wonderful new ones went up a couple of months ago from Inmarsat. Okay, it's not cheap, but but the point is that people aren't cheap, and we're all used to working from home now. So what's the difference between working from home and working from the ship? I mean, of course, there is a slight difference, but you get my point. You need to, another aim is to manage assets better. These are enormously expensive assets. And I just picked up this quote in para 3 from Ford Motor Company in 2016 when they were being run over by the electric car and by the emissions whole decarbonisation thing. And they said, we're rethinking our business models. For years, we thought about the thing and how much we sold. Now we think about usage. In other words, they've changed the questions they're asking. And I think that's a very good question. That applies absolutely to ships. You stop thinking about ships and you start thinking about services, transport services provided. When you do that, you change your perspective. Produce regulatory reports, which detail value added. Of course, reports are essential. I mean, you know, it's no good having data if you don't use it. The more you use it, the better it is. And you can make it easy to use if you work hard at it. And support through transport systems we'll come back to in a minute. Well, this is my diagram for running a fleet as a transport factory. You start out with your cluster of ships and the people serving those ships. They're a big group. You've got the technical support team and the digital support team sitting in the background, probably on land. In fact, I guess, but, you know, rolling out upgrades, harvesting digital data, processing reports. You know, do you really need the master to be sitting in his cabin filling in reports? Shouldn't somebody on shore be doing that? And checking it with him, of course, you know. And the warehouse, the data warehouse, the company systems, the links with the customer, the cargo owner, and the ports and the shipbuilders, and finally the management in the middle of the whole thing. And you know, with this sort of system and this sort of network, you can start to realize benefits from rethinking the way you look at the thing, as Ford put it. Well, let's come finally. I've nearly finished. You'll be relieved to know that makes two of us. Integrated transport systems. The bottom line here is that the global logistics systems were established 50 years ago when electronic data interchange, EDI, was very limited. I remember the guys from the container companies, OCL, moaning in the early 90s about how the problems, how little you could do with EDI. You could hardly, you couldn't run big databases. It was a pain. Today, we've got massive connectivity, but we haven't really changed the model very much. And I think, again, we need to look at the thing a bit differently to try and do that. You don't need to apologize for shipping being behind the pack, because nobody else has such a hard job to do. This is the logistics system. You've got the transport managers. Here's the vessel owners, the common carriers, the freight forwarders, and then they're feeding their information to through the export port to the various inland transport, through the system to the exporter, the inland transport system, or ShortC, the export port, and then that goes to the import port, another load of information to carriers, the information to the importer, and digital data is Maersk talk about, you did a study where they reckoned, I seem to remember there was 42 pieces of paper shipping a container from Central Africa to Europe, and two of the bits of paper got stuck together, and as a result, one got lost, and it held the whole consignment up. And these, I spent ages going through listings, getting this. These are some of the documents: commercial documents, customs documents, regulatory documents, trade finance documents. You've got to get this stuff from one computer to another. And look how many, there are probably, you talk about 50 bits of paper, there are probably 50 computer systems. And what you're looking at here, there are now systems, event streaming systems like Apache Kafka, which can deal with this problem. These are designed to let big companies with or small with legacy computer systems they don't want to let anybody into, communicate quickly, easy, reliably with small companies with only a PC, or with other big companies with different legacy systems, or with port systems, etc. And Apache Kafka was developed as it's an open source system. It was developed for LinkedIn, actually, which in 2009, that was getting such an enormous surge of data through it. They needed to be able to very rapidly transfer data from A to B from many computer systems, between many computer systems. And they use this messaging, this event-driven messaging systems to do that. And you may wonder how does Amazon manage to get, I can order a package where I'm sitting and get it delivered from Brussels tomorrow morning, and they do that with this sort of messaging software. And so it's just very difficult to do in shipping because it's so complex. There was an effort to get a single window going, but I'm not totally, I haven't heard much of that lately. Maybe it is effective. The last point of the whole is really that we should develop a new generation of ShortC services. We've done a lot about about decarbonization. We're talking about digitalization. And logistics, one of the things we can do is that look at ShortC services, because the decarbonization software works particularly, systems, not software, but the hardware, etc., probably works better in ShortC applications. And so you start looking at, for example, point-to-point transport, ShortC transport networks within Northwest Europe, which is a rapidly growing area, taking cargo directly to the port closest to the final destination. I mean, in the UK, all of the containers, or I think about 95% of the containers come into 3 ports in the southeast, and then they get loaded onto road and rail. Very few get transshipped. So the alternative, and they all travel by carbon-intensive land transport up to the north. The alternative, one alternative is you bring your very big ships into, say, Rotterdam, which has an enormous automated transshipment terminal, ShortC, deep sea, and then you have clever systems which allow companies to run feeder services, and you just ring in and book them. I'm not saying that's easy because you've got inventory things, but you've got very good automated cargo handling. You know, McDermott are doing autonomous cranes, which they say they seem to think would be very good for ports. So there's lots of things to look at there, which would be a big help. But pulling it all together, you know, people do get a bit carried away by autonomous ships. And my argument in this whole session is that we're not talking about getting an autonomous ship that does the job better. What we're talking about is thinking about our thing, our business, in a new way that enables us to use this enormous resource of digital technology and communications to do the job better. And that means meeting IMO's emission targets better and proving that you're meeting them to IMO and to your customer. Focus on increasing value added by sea transport rather than just the volume of cargo. We look at how much value you're adding, including the cost of carbon. And once you start to factor that in, you start to pay, it starts to pay for the digital systems to monitor it, I would suspect. Fine-tune existing designs while developing integrated networks. The job of management is to tell the system designers what to do. You know, it's no good, if you go back to old Theseus, it's no good getting the guy who made the sword to fight the Minotaur. I mean, he makes swords, he doesn't fight Minotaurs. What you've got to do is the guy makes the sword in the way that is suitable for killing a Minotaur, and then you need Theseus to use it effectively, and that's what adding value is about. Theseus is adding value very effectively using a piece of equipment developed by someone else. And frankly, if the sword was pretty useless, he might have had a problem, you know. So it goes back to Tim Huxley and the Formula One motor. You need to get the whole story right. Develop integrated ship systems which communicate robustly. That's one short sentence, one very long job for someone. I reckon it takes 10 years in this life. Big jobs like this take 10 years, you know. I mean, that's just the way business is. You get through by pretending they only take 2 years, and then, you know, run shipping companies as sea transport factories with integrated control. And last but not least, educate. Associations, education institutions, companies all need to do this. It's absolutely, you can't do it without the people. Whatever you say about autonomous ships, digital systems, if there's one message coming out of this rather long talk, it is that digitalization is about people, not computers. Well, there we go. I'm going to now stop sharing my screen and move myself back.
Martin, you already have a number of questions in the queue. Let me with 2 of them that I have received. what is the time scale? I mean, you have mentioned a number of difficulties. What is the time scale for being able to address them?
Oh, well, you know, I'm glad you asked that question, because I think the answer is a very difficult one. In a way, I almost answered that in my last closing sentences. Everything takes 10 years. I've found, or the projects I've done over the years, it was exactly that when I went to the farm, I said, you know, it's going to take, I said to the guys, this is going to take 10 years, and it took 10 years to really finish it. But of course, you've got the problem of motivation. And so it takes 10 years, but you take it one step at a time. And I think my advice would be the time scale should be 10 years, but you should plan that in terms of the steps which the company can take over that period of time.
Well, the second question that came through, and you're already seeing more coming as we speak. You mentioned that shipbuilders are now offering digital designs and digital equipment solutions. So how can shipping companies take advantage of that?
Well, I must say, thank you for that question again. I was very interested to see what DSME was doing. And of course, I've been picking it up from other shipbuilders. They're all working away on it. But I think the general theme of this webinar has been that the customer has to know enough about the business in order to guide the supplier in what they want and what they require. And you'll find that, like Kongsberg made their system modular so that the bits could be fitted together to suit the customer's requirements. And that, whichever way you look at it, your company must have, ideally the chief executive, because or somebody very senior working with the chief executive, must have enough understanding to, you don't need to program. I mean, I haven't programmed for years, but I wrote my first computer program 50 years ago, and the principles don't change. You need to be able to talk turkey with the supplier of your systems, and in that case, it would be the shipbuilder.
So picking up on the other questions that you also can see yourself, dear Martin, could you please share what I4 technology stands for exactly on slide 3? Okay,
this it's a sort of term that gets kicked around in consultancy areas. The derivation is that the economic historians thought that there were 3 industrial revolutions, of which the first, well, there was the pre-industrial era, then there was the, I think it was steel, then it was steam, and then it was electricity. I think those were the 3, but different consultants defined the 3 revolutions in different ways. But they were times when the whole available infrastructure to industry changed, because when electricity came in, you could do things completely differently. When the steam engine came in, you could suddenly sail without the wind, you know. And the term I4 was used to refer to the digital revolution as being the 4th revolution. In other words, it's saying this digital revolution is on the same scale as the previous 3 great revolutions in history, and you should regard it that way. So I don't know if that's, and I would agree with that. There's
you have another question on if you can have a view on artificial intelligence.
Yes, well, it's, you know, it's interesting. I mean, I lost my house keys last week, and I keep asking ChatGPT where they are, but it doesn't seem to have any good answers. You know, I think, you know, that artificial intelligence is another tool to be used. And I mean, I gave the very little example, but it's generic, of the digital system on the car, which opens the back window or the back door digitally, and then you build in little algorithms which check that all's going well, and if it senses that it isn't, it takes action, and that is a piece of intelligent technology. And I think there's enormous opportunities to do this within ship systems. But again, it's something that has to be crafted. I mean, I went to, there's a big exhibition called Big Data London, which, and a couple of years ago, I went to a lecture by a girl from Google who was programming on the car. And that's all she did. Her whole job was changing lanes. And, what she said again and again is you've got to check your code. And I think the whole problem with this sort of thing is that that artificial intelligence is very useful, but you have to keep it in its cage and make sure that it is safe, and you need to check it and check it again. And that's what she was saying. The car is smart enough to change lanes, but figuring out all the permutations of things that might go wrong is mind-boggling. So I think that holds things back. It's getting better though.
So another question that I think is really particularly important is, how can existing vessels be converted to burn clean fuel?
Oh yes, and is it possible to clean present fuel? I guess that's in two parts. The first is, can you convert to green fuel? I think the answer to the first part is that that I'm sure you can, if you take it into a repair yard and you want to say, but it's a big job. If you want to keep your diesel engine, then you would, I don't know whether the engine manufacturers do a conversion kit for, recent electronic engines, for example. That's a question to ask them. But I think converting existing ships is going to be, is technically possible, but might be rather expensive. Methanol might be easier. I think it's a technical question, but the possibility of cleaning present fuel, I guess you're sort of Dr. Razin, you're thinking here about doing the same sort of thing as taking sulfur out of desulfurizing heavy fuel oil. And I think the answer to that is no, you can't do that, because it's a hydrocarbon, and the chemical process of creating energy involves spitting out the carbon, and that's not possible. The only way you can do that is you take the heavy fuel oil. Trying to think how you do it. Yeah, you could take the heavy fuel oil, you could use it to produce hydrogen. You capture all the carbon emitted, and then you would sequester it, and you'd use the hydrogen instead of the heavy fuel oil, which means you'd have to re-equip the ship. That's a very difficult question.
Well, then let's, we are past the hour. Let's go to a final question. How enthusiastic are the shipping companies to accept the new digital system? I ran a brief list of the
problems, just in one of my last slides, in the problems that come up when you're trying to implement this stuff in shipping companies. And I wouldn't say that lack of enthusiasm is on that list at all. I would say if there was an enthusiasm index, it's over the last 10 years, it's risen, maybe 10 years ago, it was, 10. It's risen up, and 4 or 5 years ago, when places like SMM and was focusing on digital technology, the enthusiasm level was very high. Recently, it's fallen back a little bit, and it's much more. It's been pushed into the background by decarbonisation. But I don't think the problem is lack of enthusiasm. I think everybody understands a lot of the things. I'd be surprised if most people didn't sort of quite understand what I was trying to say today in this webinar. All I was trying to do was pull it together into one place. The big problem is actually doing it. And then to do it, you need organizations. And that does take time. You need organizations, education, people, and inspiration. You find that certain managers have the gift of doing this sort of thing. Others find it harder,
Martin, we were about to close the session, but then another question came in, so let's take it. Could you analyze how the new building market says, I would like to analyze the new building market. I would like to ask if the shipping cycle still plays an important role in the decision making, or whether the focus from shipping companies are more in the alternative fuels. Well,
that is a wonderful question. I have to, as a person who's plodded around conferences over the last 10 years, the conferences used to ring with arguments over where we are in the cycle. Now they ring with arguments over which fuel to use, and so the whole perspective's changed. But absolutely, the shipping cycle hasn't gone away. The industry's made a lot of money recently. We learnt in the 2 decades ago, in 2000 to 2010, we learnt that you can actually have very long cycles with very good runs followed by very bad runs. And we've just had a very bad run in, I'd say, the last 10 years, since the financial crisis has generally been quite difficult for ship owners. And we seem to, maybe we're coming to an era where we're going to get another upswing in the cycle. Who can say? So, you pay your money, and I certainly have been expecting a recession, a short-term recession, quite recently for the last couple of years. But then you often get a short-term recession before you get a big kickback. There's not much on the order book. Anyway, but that's for a different lecture, Nicholas.
Indeed, but I think, Martin, on this question, you have on one hand the decarbonization targets, the clean fuels and so on. And that is something that is mandated irrespective of the market cycle. The market cycle actually can help, because if the companies need to make all these capital investments and they are in a good part of the cycle, they can fund them more easily. So I think the cycle always plays a role, especially when it comes to investment decisions.
Yes, it does. But I think this goes back to the point I was plugging hard at in the first webinar. I think that a lot of this stuff that happens will be driven by market forces, because whenever you look at a change, you always say, what is the motivator? Nobody wants to change. What is going to force people to change? And what is going to force people to change is the high cost of fuel. And the high cost of fuel is much more powerful than IMO. I mean, IMO is a wonderful organization, and we're all very grateful to have it, but it has limited persuasive powers. whereas the market has infinite persuasive powers. And I think, you know, people will come to see that not only is the high cost of fuel vital, but actually the ability to generate the digital information that will enable you to slay the Minotaur is going to be very saleable to the cargo owners, and you will make money out of it. I think you'll be surprised, very surprised, how much money you know, whoever gets first really gets this in control. We make good money out of it.
Martin, before thanking you and closing the session, let me ask you, we're all enthusiasts of your marine economics books, and we have a fan here asking, how are you progressing with the new edition?
Well, Nicholas, I'm sorry to say it took us, when I agreed to do this series of webinars, it took a bit of a step backwards. I've been quite a few years on the 4th edition. I know exactly what I want to do. I've got lots of nice new material for it, but it's a big book and it takes a long time. And of course, if you do something like 4 webinars in such a technical area as this, it's taken me away. But once this is over, I'm back to the grindstone. And my publishers, I'm hoping to deliver it to the publishers late next year, if I possibly can. I know that sounds a long time, but it's a big book.
Well, Martin, I have to say, I'm absolutely grateful on behalf of everyone who has the opportunity to really share into your insight. Your webinars are amazing. So thank you very much for this 3rd edition today. We look forward to having the 4th one 2 weeks from now. And again, tremendous thanks. And to remind everyone that this webinar will be available for replay and you can access it upon demand.
Thank you, Nicholas. And thank you, everybody. Bye-bye now.